So far in chapter 2, we have talked about direct variation, and the opposite of direct variation would be inverse variation. So let's kind of think about what we think this would means. So if you were going to track practice and you were thinking about running laps around a track, what does your time depend on? Well, your time for one lap depends on how fast you run it, so it depends on your speed. As the speed of the runner increases, so the faster you go, what happens to the lap? Well, the faster you go, the time decreases. So as your speed increases, your time decreases. If the speed of the runner decreases, then the time increases. So we call this inverse variation because as one variable increases, the other variable decreases. Okay, so inverse means one's going up, the other is going down. Okay, should make sense. The formula then, so instead of multiplying, now we're going to be dividing. So we still have that k value, which still stands for our constant, and then we have x to the n. So x to some variable is now on the bottom. So let's see if we can practice just putting some into terms. So example A says p varies inversely as the square of q. So again, you write it just like you read it. So p varies inversely equals p equals k, and then divided by the square of q, so q squared. Part B, the number of cats C it takes to catch a mouse is inversely proportional. So C equals K over. Okay, so inversely proportional is the same idea as varies inversely to the amount of time it takes to catch those mice. So it didn't say square or cube, so it's just going to be K over T. Part C says fill in the blank with directly, inversely, or neither. So part C, the number of desks that fit into a classroom varies blank as the size of the desks. So the question I'm going to say to myself, okay, if the number of desks that fits into the room increases, well then the size of the desks must be smaller. So one goes up, one goes down. That would be inversely. Because if the size of the desks increase, I would only be able to fit in less. I would not be able to fit in more. So one up, one down inversely. Part D, the area of the circle varies blank as the square of the radius. So if my radius increases, what happens to my area? It also increases. So they both go up. So that makes it directly. And part E, the number of miles you can drive varies blank as the time you need to take an oil change. So if I need to get an oil change faster, that means I have driven more miles. So one up, one down means inversely. Sometimes these can be tricky when you're trying to fill in the blank, so I would just come up with a scenario where you're increasing one of the variables and then see what happens to the other. If they both increase, then it's direct. If one increases and one decreases, it is inverse. Okay, so when we actually solve these, it's a good, exciting day because we're going to use the exact same steps to solve them. So let's try one. Example F. The time T required to do a job varies inversely as the number of workers. So step one is still to write our equation. So time required varies inversely. So that's going to be K divided by W. It did not say square or anything like that. So there's my equation. Step 2 is still to solve for my case. So now it tells me it takes 5 hours for 8 cement finishers to do a job. So I can plug in 5 for my time and 8 for my workers. Now what's different about now is solving for K. Well, if I'm dividing by 8, I would multiply each side to cancel that out. So K here equals 40. So in step 3, same idea, rewriting my equation with that K value in place. So T equals 40 divided by W. And now I can solve my question, how long would it take for 12 workers to do the same job? So 40 divided by 12 would be 3 1/3 hours. So same idea, just kind of a little different process to solve. Example G, the number of oranges you can pack in a box is inversely proportional to the cube of the average diameter. So n equals k divided by. So again, inversely proportional gives you the k divided by. Inversely always gives you division. And then the cube of the diameter, so d cubed. So part 2, solving for k, if n equals 8, when d equals 2, okay, again, really important that you're carrying down this exponent from one step to the next. So my first step here is to say, okay, 8 equals k divided by 2 to the third is 8. So to get k by itself, I would have to multiply each side by 8. So I get k to equal 64. So step 3 is to rewrite my equation with my k value in it. So n equals 64 over d to the third. Again, you are bringing over this exponent in every single step. And now in step 4, it says find n when d equals 4. So I'm going to plug in 4, and I'm still going to have it to the third power, bringing that down to all. So n equals 1. So big diameter, I can only get one orange in a box. Probably not very realistic. Okay, there's example G. Let's try H. Z varies inversely as the square of W. So Z varies inversely, k divided by the square of W will be W squared, so W to the second power. Part 2, solving for k, I can plug in 4 for Z and 3 for W, but carrying down my second power here to each one. So that says 4 equals k over 3 squared is 9. Again, to get rid of my 9, I'd have to multiply each side. So I get k to equal 36. So step 3, I'm going to rewrite my equation with that k value, which is 36 over W squared. Again, you are carrying through that square. And now I can answer my question. It says find Z when W equals -2. Okay, and then again, I'm carrying down my square. Please be really careful. When I do a -2 squared, I should get a +4. So I get Z to equal a final answer of 9. So inverse variation, one thing is going up, the other is going down. So our equation is using division. So key ideas, inverse is division.